Justin Aquilante, ESA Sales Director, here today with Drew Smith, Product Manager for Doosan Grid Tech. Drew, as a 10-year pioneer in ESS controls development, Doosan Grid Tech has long been credited for delivering some of the most advanced intelligence systems in the industry. Walk me through what you're driving in program advancements this year.
Thank you for having me, Justin. Over the last 10 years, something that Doosan Grid Tech has done and that we continue to do today is go straight to our customers to help them understand what they want. That's why we're releasing a new system architecture that allows for an ease of scalability, improved performance, and modularity. When Doosan Grid Tech first started, a 5-megawatt system was considered a huge system, and utilities were the major owners of energy storage systems. Now, there's an even wider range of system owners, and an even wider range of use cases. That's why we've redesigned the intelligent controller, which is what we call the DGIC, so that we can meet the needs of the simplest system as well as the needs of the most complex. And most importantly, we're not going to charge a customer who wants a simple system the same price as we would for a customer that wants the most complex. And on top of this design, it allows for us to easily scale our systems so that the effort to get a system up and running on a 1-megawatt system isn't really that much different than a 100-megawatt system or even larger than that. We also know our customers want improved performance and response time. The DGIC can now meet the fast frequency response requirements of ERCOT and other markets as well. The DGIC can process signals and dispatch commands in under 10 milliseconds, allowing for overall site response times to achieve a rated output in under 150 milliseconds. On top of this, the DGIC can offer availability of up to 99.9% while still running these frequency requirements. We also know that owners lose money when the system's down, even if it is for planned maintenance. That's why the DGIC has 0 downtime updates, so customers can take advantage of these updates as soon as they become available, and they can take advantage of these improved capabilities without having to wait until their next planned maintenance. It isn't just the DGIC where we've made improvements. The performance analyzer, which is what we call the PA, has had some improvements as well. It can now do ITC tracking, solar performance tracking, as well as automated reporting. We're delivering a DC coupled system later this year in Massachusetts, and the compliance reporting is going to be taken over completely by the PA, where the reports will be processed and distributed directly to the Massachusetts Department of Energy Resources for the SMART and CPEC programs. And our customers aren't going to really have to put any effort into doing anything there. It isn't just these 2 programs as well. We're able to, the PA can do customizable reporting for customizable stakeholders. Finally, we've made some pretty impressive improvements to our user interface, which we want to be all things to all people. It starts off with a customizable dashboard where the customer can set up to have the views that they want so they can quickly reference the information that they need. It also has tabs on reporting, analysis, and easy-to-use scheduling. And to really stay true to our roots, you can not just see the overall system performance, but an operator can drill down into the performance of the individual components.
Drew, with 2 100-megawatt systems coming online later this year, what have you learned about delivering controls in the field for large-scale projects?
Well, firstly, it's been really exciting to work on these large systems. And most importantly, though, it's validated our focus on modular design. We're able to take advantage of this modular design through the MESA standard interface, which allows the DGIC to easily adjust to meet our customers' needs. We're currently working to deliver control software for AbleGrid at the 100-megawatt Chisholm Grid battery energy storage project in Texas, and working with Vina Energy to provide best design and delivery for the 100-megawatt Wandawan project in Australia. These projects have different batteries, different PCS, and different use cases, but the modular design that the DGIC is built on helps us easily scale and take into account these differences. And most importantly, it reduces integration on these large projects, saving our customers money. We've also been able to take advantage of the Doosan Grid Tech in-house test lab. This test lab allows us to bring the hardware in-house, so that we can reduce time and cost from doing on-site testing. We can also take advantage of our simulator, which has sophisticated emulation capabilities and can take into account component delays so that we can know how the system is going to perform before the electrons even start flowing. Both of the systems I previously mentioned are transmission systems and therefore must meet really strict grid codes and be efficient in terms of how they scale and perform. That's where our sophisticated team of software development and power system engineers come in to ensure that the system is designed, tested, and delivered to meet these requirements.
Drew, what do customers need to know about your energy management system that puts you a cut above the competition?
Our goal is to help solve our customers' problems, find out their needs, and meet their demands. That is why we've designed the DGIC to be extremely flexible. When a customer comes to us to outline what they want their EMS to do, we don't want to tell our customer, here's what our EMS does, take it or leave it. Or, sure, the DGIC can do that, but we only just offer one package, and you're going to have to pay for these additional features we've developed. When a customer comes to us, we sit down with them to walk them through our menu of features so that they can choose the features that are right for them, and they'll know that we're not going to tack on any additional bells and whistles. The DGIC allows us to meet the needs of the individual customer without forcing on them the needs of every customer. We also know throughout the market, and particularly for our customers, that cybersecurity is extremely important. That's why we're flexible in how the system is set up. The DGIC can be hosted 100% on-premise or a combination of on-premise and in the cloud. And we allow our customers the choice to get the setup that really is right for them. We've also been streamlining our integration process. This allows flexibility to our customers to perform the integration scope in-house or continue to have Doosan Grid Tech perform those services for them. We'll train our customers to integrate the DGIC into their systems, and from that point forward, the customer can choose how they want to do the integration based on their scope appetite. I previously talked a little bit about the MESA standard interface and how that gives customers the choice on what hardware they want to do. This isn't just important at the outset of the project, but as they decide to scale later on, they aren't tied to the equipment they used at the original delivery of the project. They can choose, even in the future, what equipment is right for them. Now, I've gone over a few of these things, but really we've designed the DGIC to be extremely flexible throughout all aspects of the system, and that is what really sets us apart.
Drew, what guidance can you offer customers who are trying to create deeper, long-term value from their EMS?
Well, I don't think I really have to say this, but as we know, energy markets are constantly changing. And that's why we try to guide our customers to not just think about what their system can do in the short term, but how their system will need to adapt over the 10, 20, 25 plus years that their system is performing. Once the system's in the ground, there are very few cost-efficient levers that can be pulled to get the system to adjust to how a customer wants it. And the EMS is the main lever that can easily adapt on a cost-efficient basis. Recently, we've had a number of customers reach out to us about retrofitting their software. In some cases, the software they chose at the outset of the project is too rigid. In other cases, the use cases the customer outlined aren't as profitable as they originally intended, and their software couldn't pivot to meet their new needs. As energy markets change and our customers' use cases may no longer be relevant, we don't want them to be in a situation where they have to take down their system for multiple months to replace the EMS. And that's why choosing an adaptable EMS is key. If things change in the future, the DGIC design gives customers the flexibility to change how their system operates. Customers can update their use cases to meet and adapt to new market demands, and they'll also know that the DGIC will continue to evolve with the market. Our goal is to be with the system owners, even if their needs change in 10 years. And to go back to something we talked about before, and the zero downtime updates and upgrades, we're able to make these improvements without taking the system down, allowing our customers to maximize their revenue potential. We want to be a long-term partner for our customers and support them over the term of the project. The DGIC is flexible for what our customers need now, and in an unpredictable power generation and distribution landscape, the DGIC adapts for our customers along the way.
Drew, how can people get in touch with you to learn more?
I'm happy to always talk about Doosan Grid Tech and the DGIC, so please feel free to reach out to me at drew.smith@doosan.com.
Drew, great insights today. We learned a tremendous amount about Doosan Grid Tech, the DGIC, your in-house simulator for testing, and your zero downtime during upgrades, allowing customers to maximize revenues. Thank you for joining us today.